Assalamualaikum. Hi. For this video, we continue with the chapter 2 for subject wave and vibration. The topic will be superposition. And for this video, the subtopic will be superposition of two perpendicular simple harmonic motion with the same frequencies and also for the different frequencies that we call as a Lissajous figures. So for this calculation, we discuss on the firstly will be two perpendicular simple harmonic motion that we call both different direction. One in the x direction and another one will be in the y direction. So for x direction, we have a1 cos omega t plus theta 1, and for y direction will be a2 cos omega t plus theta 2. A1 and A2 is an amplitude, okay, for the x and y. Omega is the same right now because we discuss with the same frequency. And the theta, the phase angle for x1, x will be theta 1, and for y will be theta 2. The calculation about a little bit complicated, but let me show you. First, we're dealing with the x, okay? So we bring a to the x, so we have x over a1 equal cos omega t plus theta 1. Now, we are using the trigonometry identity. So for cosinus cosine A plus B, example, you can have cosine A, cosine B minus sine A, sine B. Okay, so let me show you the trigonometry identity here. Okay, so here cosine A plus B, you can get cosine A, cosine B minus sine A, sine B. So you can get here cos omega t cos theta 1 minus sin omega t sin theta 1. And then we bring this cos omega t in front. Okay, so right now this is not in the equation now. Okay, so bring cos omega t. So we have 1 cos theta 1 for x a1 plus sin omega t theta 1. So let me show you. Right now x, so I bring this to the, so I have here cos omega t cos theta 1 equal to x over a1 plus sin omega t and theta 1. So cos theta 1 you can bring here. So that's why you can get this equation. And then we are moving to the y-axis simple harmonic motion. Again, we'll bring a2 here. So we have y over a2 equal to cos omega t plus theta 2 using the trigonometry identity. So we can have here cos omega t cos theta 2 minus sin omega t sin theta 2. So this will be the equation. So we have here cos omega t. We replace this cos omega t. So then we have y over a2 equal to cos omega t, which is we have 1 over cos theta 1 times x over a1 plus sin omega t sin theta 1 times cos theta 2 minus sin omega 2 sin theta 2. So now, this is first part. We need to deal with this equation. First, we need to bring this cos theta 1 to the left. Okay, left side. So this one also you need to times cos theta 1 over cos theta 1. So then we can bring cos theta 1 at the left side. So we have y over a2 cos theta 1 equal to x over a1 times the cos theta 2 cosine theta 2 plus sine omega t sine theta 1 cos theta 2, we times both with the cos theta 2 minus sine omega t sine theta 2 cos theta 1. Okay. So we bring x and y to the one side, and we make this cos theta x over a1 cos theta 2 positive. So we can have here x over a1 cos theta 2 minus y over a2 cos theta 1 equal to, we start with this. This will be the positive. Okay. Sine omega t sine theta 2 cos theta 1 minus for this one. Okay. Sine omega t sine theta 1 and cos theta 2. We have same sine omega t factorized. So you can have here so we have sine theta 2 cos theta 1 minus sine theta 1 cos theta 2 using the trigonometric identity. This one is sine b sine cos a minus sine a cos b. You can check the trigonometry here. Okay, so you can see at the top we have sine sine a cos b minus sine b cos a. Okay, sine a cos b. I think this one is B. Okay, so some mistake here. Just find out. Cut. Okay, so sine A cos B, sine B cos A. So the answer will be sine A minus B. Is A right now is theta 2. So we have here sine omega t sine theta 2 minus theta 1. Okay. This will maintain x over a1 cos theta 2 y over a2 cos theta 1. Okay, and then with power of 2 everything, okay, will be power of 2. So we complete of one equation. So this will be number 1. Again, we need to find a second equation. We start with the basic x and y also. Okay. But right now we try to find the sine omega instead of the cos omega. So again, x over a1 cos omega t cos theta 1 minus sine omega t sine theta 1. Okay. For y over 2 cos omega 2 cos theta 2 minus sine omega t sine theta 2. So this using the trigonometry identity. And right now we will bring sine omega t at the front. So we have here 1 over sine theta 1 minus x over a1. Since this is minus, we bring here to left, become positive. X over a1 become negative. So we have cos omega t cos theta 1 minus x over a1. And we replace this with this sine omega t. So right now we have here 1 over a2 cos omega t cos theta 2 minus 1 over sine theta 1 here, that we replace the sine omega t here. So we have 1 over sine theta 1 times cos omega t cos theta 1 minus x over a1 times the sine theta. So we rearrange again. So y over a2, we bring sine theta 1 to the left. So times sine theta 1. So since it doesn't have sine theta 1 here, times tan theta 1 over sine theta 1. So you have here cos omega t cos theta 2 sine theta 1. Yes. Cos omega t cos theta 1 sine theta 2 minus minus, you can get plus x over a1 sine theta. Again, okay, we collect everything in the one side for x over a1 and 1 over a2. So we make the x over a1 positive, so this one will be negative. So x over a1 sine theta 2 minus y over a2 sine theta 1, so equal to, so the positive negative we change, this one will be positive, so we have cos omega t, both have cos omega t, so we have here cos theta 1 sine theta 2 minus cos theta 2 sine theta 1. Okay, so trigonometry identity again, so you can hear x over a1 sine theta 2 sine theta 1 square, okay, for cos square omega t. For this one, we convert to the sine theta 2 minus theta 1 identity, and because we square everything, this one is a square. So finally you can get this equation number 2. Sorry, number 2. So we have equation number 1 and equation number 2. Little bit alternate because we have here x over a1 cos theta 2. For this one, we have sine theta 1 and sine theta 2. And this one is cos omega t. This one is sine omega t. Okay, we add up both equations. Okay, we add up of both equation. So we have here x power 2. So we have here x square over a1 square. Okay, cos square theta 2 plus y square over, sorry, this is power of 2, both of them, cos square 1. So we have minus y over a1 a2 cos theta 1 cos theta 2 2. Okay, so this for the first one. Okay, and the second one would be to be plus, okay, y square over 2 plus sorry, sine theta 1 square plus x square over 1 a1 square, okay, all of this square, sine square theta 2 minus 2xy over a1 a2 sine theta 1 sine theta 2. Okay, and for the right side, we have here cos square omega t times sine square omega theta 1 theta. So this one we have same. Okay, sine square theta 2 minus theta 1. So factorize sine square theta 2 theta 1. We bring it the side, and then we have here cos times cos square omega t plus sine square omega t. So we know that cos square theta plus sine square theta is equal to 1. Okay, trigonometry. So we have here only sine square theta 2 minus theta 1. So we add everything here. We have x square over a1. Sorry, x over a1 square. So here we have cos square theta 2 plus sine square theta 2. Then we have here plus y square over a2. Also cos square theta 1 sine square theta 1 square theta 1. Then we have here minus 2xy, same, okay. Minus 2xy, factorize here, for a1 for sine 2 plus cos 1 cos 2. All of this equal to sine square theta 2 minus theta 1. Theta 2, theta 1. Okay. And this will become easy because we know that cos square theta plus sine square theta equal to 1. This one also equal to 1. And this we change to the trigonometry identity. You can get here cos theta 2 minus cos minus 1. Cos theta 2 minus 1. So finally, you can get the equation for the perpendicular, okay, which is the final equation for same frequency. Okay. So now this discussion, okay. So we know that theta 2 minus theta 1 is equal to delta, okay. Delta make easier for us to compare. So right now delta is the difference between phase angle for x and y. What happened? Example, if the difference between both of the phase angle is 0, okay, either both have a 0 phase angle or same phase angle, so that makes the differential between difference between two will be 0. So we know that sine 0 is equal to 0. Cosine 0 equal to 1. So we have here the equation will be x square plus y square over square, and then we bring 2x to the right side because this equal to 0. Yeah, 2x. Sorry, we just stay in the left. Okay, 2xy over a1, a2 go to 0. So this is same with the x over a1 minus y over a2. And the graph will be like this. You can get the straight line. Then we continue if we have maybe you can take the easiest one will be pi over 2 if the delta is equal to pi over 2. So pi over 2 sine pi over 2 will be 1. Cosine pi over 2 will be 0. So you can get here x square over a1 square plus y square over square equal to 1. So this will be okay. So this will be the graph. Okay. So this will be the graph for the for pi over 2. Okay, pi over 2 phase angle. And we try to find the pi over 4. Difficult to show from the calculation. So maybe you can check from this graph. Pi over 4 should be, okay, the ellipse will be on the right side. Okay, so when we change the value from this calculation, okay, example, if we get 3 pi over 2 or pi, okay, we know that sin pi is equal to 0 and cos pi is equal to 1, okay, sorry, negative 1, okay, and the graph will be a little bit same, but we can get x over a1 plus y over a1, a2. So we can see that the graph will be something like this. Okay. So by changing the phase angle, okay, so we can get the different value or different graph of this simple harmonic motion for the perpendicular. So it brings us to the next problem will be, we call it as a Lissajous figures. When what we had discussed before, more on the this 1/1 means that for the frequency, okay, this frequency for x, the frequency is omega and y also omega. Okay, so the ratio is 1:1, and this will be the delta, okay, for 0, pi over 4, pi over 2, 3 pi over 4, and pi. This is what we had discussed before. So right now, what happened if the frequency different? Okay, omega 1 is different with the 2 compared to omega 2. So they put the ratio, if the omega 2 is equal is 2 times the omega 1, 3 times omega 1, or omega 2 the ratio is 2 over 3. So what happened to the graph for the different phase angle? So I will show you in the Desmos, okay, for the different ratio. So here for so this will be okay. So this will be the output for delta equals 0 for ratio 1 over 2. And when we change to the different graph, okay, so we can get here. So this one for the pi over 2, okay, pi over 2. So for pi over 2, you can get this graph, okay. For pi over 4, is something, okay. And when we increase, so it becomes something like, become 3 pi over 4, and then pi, the same shape but the different direction, and they keep continue. And for when we change the frequency, of course the equation will be changed and the graph will be complicated. So that will be part of the Lissajous figure, and it's very interesting if we can draw by hand for the Lissajous figures, and I'm usually explaining in the class. This is very interesting to get the output what happen if you use the right frequency and also the parameter. Okay, so that's all for this video, and we see for the next chapter another video later. Okay, bye.